Hi guys and welcome back. In this lecture we're going to be discussing basic feature detection. Okay, so the human brain does a lot of pattern recognition to make sense of raw visual inputs. So basically after the eye focuses on an object, the brain identifies the characteristics of the object, such as its shape, color, texture, and then compares it to the characteristics of familiar objects to match. In computer vision, that process of deciding what to focus on is called feature detection. A feature can be formally defined as one or more measurements of some quantifiable property of an object, computed so that it quantifies some significant characteristics of an object. This is based on a book by Kenneth Castleman. So an easier way to think of it is a feature is basically an interesting part of an image. So what makes a good vision system characteristic? Okay. So a good vision system should not waste time or processing power analyzing the unimportant or uninteresting parts of an image. So basically, feature detection can help determine which pixels to focus on. We will focus on the most basic type of features, which are blobs, lines, circles, and corners. If the detection is robust enough, a feature is something that could be reliably detected across multiple images. And this is basically very important when you're doing video sequencing or basically doing detection across multiple images or sequential frames. Let's look at our detection criteria. So how do we describe the features that can also determine the situations in which we detect the features? So our detection criteria for the feature determines whether we can find the feature in different locations of the picture, which means its position invariant. Find the feature if it's large or small, near or far, that is basically scale invariant. Find the feature if it's rotated at different orientations, or in other words, rotation invariant. So let's start and take a look at blobs. What are blobs? Well, blobs are basic objects or connected components, regions of similar pixels in an image. The examples are as follows. A group of brownish pixels together which might represent food in a food detector. A group of shiny metal-looking pixels, which on a door detector could represent the doorknob. Or a group of matte pixels, or matte white pixels, which on a medicine bottle detector could represent the cap. Now, blobs are valuable in machine vision because many things can be described as an area of certain color or shade in a contrast to a background. Okay, in finding blobs, so morphological operators such as thresholding can be used to find objects that are lightly colored in an image. If no parameters are specified, the function tries to automatically detect what is bright and what is dark. Okay, taking a look at blob measurements. After a blob is identified, we can basically measure quite a lot of things from it, like the area, width and height, finding the centroid, counting the number of blobs, taking a look at the color of the blobs, looking at the angle or its rotation, finding out how close it is to a circle, square, or rectangle, or basically we can compare its shape to another blob. Now, if you look at blob detection and measurements, blobs are mostly easily detected on a binarized image, so that's basically a black and white image. 2, it returns a feature set, so it's a list of features about the blobs which are found, and has a set of defined methods that are useful when handling features. It draws each feature in the feature set on top of the original image, and then displays the results. So after the blob is found, several other functions provide basic information about the feature, such as its size, location, and orientation. Okay, so that's it for this lecture. In the next few lectures, we're going to be busy with vision-based apps, back to app development in LabVIEW. So app 3 will be blob detection. So I'll show you how to go about blob detection, how to detect multiple blobs in an image and how to group them and how to get measurements from them. And then in app 4, we're going to be doing something very exciting. We're going to be getting distance from the size of the blob. So if we take a circle, the width of the circle is inversely proportional to the distance to that circle or that marker. So we'll be doing this in real time, and I hope you're excited because this is some cool stuff. Imagine measuring distance from an image in real time. Okay, so I'll see you then.